Hello everyone. In this video, we are going to learn about next module, which is hydraulic turbine. Okay, hydraulic machines, in which hydraulic turbine we are going to study in this module. I hope you have uh, familiar with the word turbine. Okay, in hydroelectric power plants, there is a turbine which is fitted to produce the electrical energy. Now we'll thoroughly study what is turbine, what is the classification of turbine, different parts of turbine. Okay, now first, introduction of turbine. Okay, now hydraulic machines. What is mean by hydraulic machines? Hydraulic machines are the machines which convert either hydraulic energy into mechanical energy और मैकेनिकल एनर्जी इनटू हाइड्रोलिक एनर्जी. ओके, जो मशीन्स हाइड्रोलिक एनर्जी को मैकेनिकल एनर्जी में कन्वर्ट करते हैं, विच इज फर्दर कन्वर्टेड इनटू इलेक्ट्रिकल एनर्जी, मींस हाइड्रोलिक एनर्जी को मैकेनिकल एनर्जी में कन्वर्ट करने के बाद अगर वो इलेक्ट्रिकल एनर्जी में कन्वर्ट होती है, देन दैट मशीन इज ऑल्सो कॉल्ड अ हाइड्रोलिक मशीन. और मैकेनिकल एनर्जी को जो हाइड्रोलिक एनर्जी में कन्वर्ट करते हैं, दैट मशीन इज ऑल्सो कॉल्ड एज अ हाइड्रोलिक मशीन. ओके, अभी दो पार्ट्स मैंने बताए हैं. ये एक तो हाइड्रोलिक एनर्जी को जो मैकेनिकल एनर्जी में कन्वर्ट करता है वो, एंड द सेकेंड पार्ट इज मैकेनिकल एनर्जी इज गेटिंग कन्वर्टेड इनटू hydraulic energy. Okay, now the machine or the hydraulic machine which converts hydraulic energy into mechanical energy, that machine is called as a turbine, hydraulic turbine. Okay, or second part is mechanical energy converted into hydraulic energy. Now when the hydraulic machine is converting a mechanical energy into hydraulic energy, then that hydraulic machine is called as pumps. Okay, first is hydraulic turbine and second is your pumps. Now here in this whole module, we are going to study hydraulic machines or hydraulic turbine. Okay. Now I have discussed what is turbine and what is pump. टर्बाइन क्या होता है? टर्बाइन हाइड्रोलिक एनर्जी को मैकेनिकल एनर्जी में कन्वर्ट करता है एंड फर्दर इट इज कन्वर्टेड इनटू इलेक्ट्रिकल एनर्जी. ओके, सो टर्बाइन्स आर यूज्ड इन द हाइड्रोइलेक्ट्रिक पावर प्लांट्स. Now pumps are converting the mechanical energy into hydraulic energy. Okay, so here turbine and pump part is over. Now the turbine introduction. As I have explained, turbine is nothing but the hydraulic machine which converts hydraulic energy into mechanical energy. Okay, now here this mechanical energy is used for running the electrical generator. Okay, this mechanical energy which is converted by turbine, this is used for running a electrical generator which is directly coupled to the shaft of turbine, which is directly coupled to the shaft of your turbine. Okay, so what happened? The mechanical energy is getting converted into electrical energy. Okay, here why mechanical energy is converted into electrical energy? Because the electrical generator is directly coupled to the shaft of your turbine, therefore that mechanical energy is getting converted into electrical energy. Okay, I hope you understood. Now the electrical power which is obtained from the hydraulic energy, that power is called as your hydroelectric power. That power is called as hydroelectric power. So the whole power plant is known as hydroelectric power plant. Okay, now at present these hydraulic turbines are classified into several types, but before that we are going to learn the general layout of your hydroelectric power plant so that you can easily understand what is the function, actual function of the hydraulic turbine. Okay, so we'll move further for general layout of hydroelectric power plant. Here in this figure, you can see that there is a dam. This hatched portion shows a construction of dam or structure of dam, and from this a penstock is provided. Here a penstock is provided, and at the end of this penstock there is a nozzle. Okay, nozzle part you have studied in fluid mechanics subject. Nozzle is nothing but the a part which is reducing in diameter. Okay, now i'll uh, I'll explain the parts of this hydroelectric power plant. First, a dam is constructed on the river to obstruct the water which is flowing from the river. Secondly, a pipe of a large diameter which is called as penstock. This is penstock. Penstock is nothing but the pipe of a very large diameter. Okay, that penstock is constructed or laid on the dam, in the dam section, so that the water from the reservoir will flow from this penstock, and lastly will obstruct or will impact on these vanes of turbines. Okay, now thirst thirdly, these pipes, a penstock, these are of large diameter. So these pipes are made of steel or a reinforced concrete. Okay, these pipes are of large diameter, so the pipes are of made up of steel, either steel or of reinforced concrete. Okay, now from this there is a nozzle fitted, which is nozzle is nothing but the uh, end of a pipe which is having a diameter smaller than pipe diameter. Okay, now here a turbine is provided, which is having different types of vanes fitted on the wheel. Okay, which is having different types of vanes. These are the vanes. Vanes is nothing but the cup shaped arrangement which is attached to the circular periphery of turbine. Okay, now this is your head race, which is the uppermost level of the reservoir. Now if I'll draw the dotted portion or dotted line through this dam, the headrace will extend to this level. Okay, now this is your tail race. Okay, tail race, which is a channel which carries water away from the turbine after the water has worked on turbine. Okay, that means जब भी नोजल से वाटर वेन्स पे स्ट्राइक होगा, then what happened, the veins will circulate. Okay, veins will move circularly. Now after striking, the water will fall to the downward. नाउ हियर एक चैनल प्रोवाइड किया होता है, जो ये जो वाटर फॉल हो रहा है, दैट वाटर विल कैरी थ्रू दैट चैनल. Okay, that channel is called as tail race. Head race is nothing but the uppermost level of reservoir, and tail race is the channel which carries the water away from the turbine after striking the turbine. Okay, now that uppermost level of that channel is called as your tail race. Now the difference between this head race and tail race is your gross head, here indicated gross head, that is Hg, and this is your net head. And Hf is nothing but the frictional losses, loss of head, Hf. Now this is the general layout of hydroelectric power plant. It's very easy. I hope you understood this. When a dam is constructed, through that reservoir, the penstock is fitted, and through the penstock, water is moving further. At the nozzle, the water strikes in the form of jet on the veins, and when jet strikes this, the veins will move circularly. Okay, and after striking, the water will carry through the tail race. This is about the general layout of hydroelectric power plant and the introduction of turbines. What is turbines and how it works. Now we'll move further for the head of turbine or heads of turbine. What is the heads of turbine? Now in this figure you have you can see that there are two heads. First is gross head and second is net head. Okay, so gross head, what is gross head? Gross head is denoted by hg, and it is the difference between head race level and tail race level when no water is flowing. Okay, difference between head race level and tail race level when the no water is flowing. Here, this difference between head race and tail race is your gross head, and it is indicated or denoted by hg. Now second is net head. Now this net head is also called as effective head, and it is defined as the head available at the inlet of turbine. Okay, head available at the inlet of turbine. That means here in this diagram you can see this is the height, that means the head available at the inlet of turbine. This is your turbine's inlet. So for calculating the head available at inlet of turbine, you have to consider this hf also. So here h is I have written h as hg plus hf. Okay, when water is flowing from the head race to the turbine, loss of head due to friction between the water and penstock will occur. ओके, मतलब जब भी वाटर रिजर्वायर से पेनस्टॉक थ्रू टरबाइन तक पहुंचेगा, तब पेनस्टॉक का सरफेस एंड द वाटर in between these two there will be friction. Okay, so friction की वजह से यहाँ पे loss of friction होगा. तो loss of friction is nothing but your head loss. Okay, तो ये जो head loss है, this head loss is also to be considered while calculating the net head. So when water is flowing from this head race to the turbine, loss of head due to friction between the water and penstock occurs. That means though there are here in this diagram you can see there is a bend, there is a opening inlet, but these are the minor losses. Okay, these are the minor losses, but hf, that is head loss due to friction, this is the major loss, so we have to consider the hf. So if hf is the head loss due to friction between penstock and water, then the net head will be h equals to hg minus hf. Okay, hg minus hf. Here hg is nothing but your gross head. ओके, ग्रॉस हेड. सो अगर ग्रॉस हेड से फ्रिक्शनल लॉसेस और हेड लॉसेस हम लोग सब्सट्रैक्ट करते हैं तो हमें क्या मिलेगा? दिस नेट हेड. ओके, सो ग्रॉस हेड विल बी hf plus net head. Okay, through this diagram you can clearly see that hf plus net head will be equal to gross head, but net head will be gross head minus hf. ओके, नाउ HF कैसे कैलकुलेट करते हैं? यू हैव ऑलरेडी idea how to calculate the HF. HF is nothing but the head loss due to friction, and the formula for HF is 4FLV square divided by 2GD. 4FLV square divided by 2GD. Now यहाँ पे जो L है, that L will be length of penstock and V will be the velocity of flow in the penstock. Okay, because जो frictional losses है वो फ्रिक्शनल लॉसेस ओनली पेनस्टॉक में हो रहा है, तो पेनस्टॉक में से ही फ्रिक्शनल लॉसेस हमें निकालने हैं, तो वाटर जो फ्लो हो रहा है वो पेनस्टॉक थ्रू फ्लो हो रहा है, सो वी हैव टू कंसिडर द वेलोसिटी ऑफ वाटर इन द पेनस्टॉक. Okay, so V will be equals to the velocity through penstock, and length is nothing but the length of your penstock. L is length of penstock, and obviously D will be the diameter of penstock. Okay, so 4FLV square divided by 2GD will be your frictional losses or the loss of head. Now this is about the gross head and net head. These are the two heads of turbine. Now we'll move further for efficiencies of turbine. Okay, efficiencies of turbine. In this, there are four important efficiencies of turbine. First is hydraulic efficiency, second is mechanical efficiency, third is volumetric efficiency, and last is overall efficiency. Okay, now first, hydraulic efficiency. Hydraulic efficiency is denoted by an eta H, here eta H for hydraulic, and efficiency is obviously denoted in eta. So eta H is hydraulic efficiency. Okay, now it is defined as, hydraulic efficiency is defined as the ratio of power given by water to the runner of turbine to the power supplied by the water at inlet of turbine. Okay, here ratio है, दो powers का ratio है. First power is the power given by water to the runner. Now this power given by water to the runner is nothing but the power delivered to the runner. Okay, power delivered to the runner. रनर, अभी रनर क्या होता है कि रनर इज नथिंग बट योर रोटेटिंग पार्ट ऑफ टरबाइन. नाउ जब भी जेट जो है, वाटर जेट जब भी स्ट्राइक होगा, टरबाइन पे स्ट्राइक होगा, तब जो रोटेट हो रहा है पार्ट, टरबाइन का जो पार्ट रोटेट हो रहा है, दैट पार्ट इज कॉल्ड एज योर रनर. Okay, in further slides I will explain the parts of turbine. So just for the introduction, what is runner? Runner is nothing but the rotating part of turbine. Okay, and on which the vanes are fixed. Vanes I have already explained. Vanes is nothing but the cup shaped arrangement which is attached to the runner. Okay, so here hydraulic efficiency is nothing but the power given by water to the runner. That means the power delivered to the runner to power supplied by water at inlet of turbine. Okay, that means power supplied at inlet. So the ratio will be power delivered to runner and power supplied at inlet. Okay, this is called as your hydraulic efficiency. Now power at the inlet of turbine is more, so this power goes on decreasing as the water flows over the vanes of turbine due to the hydraulic losses, as the vanes are not smooth. ओके जब भी जेट ऑफ वाटर इन स्ट्राइक होगा, मतलब वेन्स पे स्ट्राइक होगा, तब जेट की जो पावर होगी, मतलब इनलेट, टरबाइन का जो इनलेट होगा वहां की जो पावर होगी, दैट पावर विल बी हाई। ओके, बट जैसे रनर रोटेट होगा एंड वाटर स्ट्राइक होते जाएगा, वैसे वैसे क्या होगा कि पावर डिक्रीज होती जाएगी, क्योंकि जो वेन्स है दैट आर इन कर्व शेप्ड, okay, and that are in moving state, and the surface of that veins are not smooth. So क्या होगा कि लॉसेस होंगे वहां पे, फ्रिक्शनल लॉसेस आएगा एंड माइनर लॉसेस भी आएंगे. सो ड्यू टू द लॉसेस दैट पावर विल goes on decreasing. Therefore, power delivered to the runner of turbine will be less than that of the power available at inlet. Okay, so mathematical expression of that is eta h is rp divided by wp, runner power divided by your inlet power, that is water power. Now ये जो wp है, that wp is high than that of your rp. Okay, that means power delivered to the runner is higher or increased than that of the power delivered to the runner. Power delivered at inlet, that is power delivered at turbine, is higher than the power delivered at runner. Okay, this is about your hydraulic efficiency. Now रनर पावर जो है, वो रनर पावर हर एक टरबाइन के लिए कैसे कैलकुलेट करनी है एंड हाइड्रोलिक एफिशिएंसी कैसे कैलकुलेट करनी है, दैट विल बी डिस्कस्ड इन फर्दर वीडियोस ऑफ पेल्टन व्हील टरबाइन, कैप्लान टरबाइन एंड फ्रांसिस टरबाइन. नाउ फॉर दिस वाटर पावर कैसे कैलकुलेट करते हैं वो मैं बताती हूँ. वाटर पावर विल बी कैलकुलेटेड by using WP equal to rho GQH divided by 1000 kilowatts. Okay, in kilowatts अगर आपको water power निकालनी है in SI units, then water power will be calculated by rho GQH. H is nothing but your net head, rho GQH divided by 1000. Okay, rho GQH divided by 1000 will be your water power, that is the power supplied at the inlet. Okay, this power जो मैंने अभी फॉर्मूला बताया, this formula will give you the power in kilowatts. Okay, because we are going to divide it in 1000. Now second is your mechanical efficiency. अभी हाइड्रोलिक एफिशिएंसी जो है वो ईटा एच से डिनोट करते हैं. सो द मैकेनिकल एफिशिएंसी विल बी डिनोटेड बाय ईटा एम. ओके, एम फॉर मैकेनिकल. नाउ मैकेनिकल एफिशिएंसी, here the power delivered by water to the runner of turbine is transmitted to the shaft of turbine. Okay, shaft, that is the central part of your turbine. जो भी वाटर पावर, जो भी वाटर की जो भी पावर है जो रनर को सप्लाई की हुई है, दैट फर्दर ट्रांसमिटेड टू द शाफ्ट ऑफ टरबाइन. ओके, नाउ ड्यू टू द मैकेनिकल लॉसेस द पावर अवेलेबल एट द शाफ्ट ऑफ टरबाइन is less than the power available at the runner of turbine. That means power delivered by turbine. अभी पहले क्या था कि जो इनलेट है टरबाइन का, जो इनलेट है टरबाइन का, वहां की पावर क्या होगी, हाईएस्ट होगी. ओके, आफ्टर दिस द पावर इज ट्रांसमिटेड टू रनर. अभी रनर जो है वो रोटेट हो रहा है, रोटेट होने की वजह से वहां पे हेड लॉस होंगे, माइनर लॉस होंगे, तो वहां की पावर क्या होगी, इनलेट से कम होगी. दैट मीन्स इट विल बी डिक्रीज्ड and then this power is transmitted to the shaft. Okay, so apparently the power will goes on decreasing up to the shaft. So the shaft power will less than the power at the runner. Okay, so here this mechanical efficiency is nothing but the ratio of power available at the shaft of turbine टू द पावर डिलीवर्ड टू द रनर। ओके, जो भी पावर आपकी शाफ्ट की पावर है, that power and your runner power, the ratio is called as mechanical efficiency. Okay, now mathematically this is written as eta m equals to sp divided by rp. now ये जो sp है, that sp can be written as bp also, that is called as your shaft power, that is power of shaft of turbine available at the shaft of turbine. So this is your mechanical efficiency. Okay, now we'll move further for volumetric and overall efficiency. Now what is volumetric efficiency? जैसे हाइड्रोलिक एंड मैकेनिकल एफिशिएंसी डिनोट की है ईटा ईटा एच एंड ईटा एम से, वैसे सेम हाइड्रो हाँ वॉल्यूमेट्रिक एफिशिएंसी भी डिनोट की है ईटा वी से. वी स्टैंड्स फॉर volumetric. Okay, now the volume of water striking the runner of turbine is slightly less than the volume of water which is supplied to turbine. Okay, this is the general statement and it is very simple, that the volume which will strike the runners or which will strike the turbine, that water will be slightly less than the water at inlet of turbine. Okay, water which is supplied to the turbine. So some of the volume of the water will discharge to the tail race without striking the runner. ओके, मतलब जो भी वाटर है वो जो स्ट्राइक हो रहा है आपके रनर को, वो इन द फॉर्म ऑफ जेट स्ट्राइक होगा. ठीक है, बट the distance between the exit of your jet and the entry point of your runner, there will be some distance. Okay, and that through that distance the water will be in suspension. Okay, so क्या होगा कि some amount of water will fall to the tail race without striking. ओके, मतलब जो भी वाटर आपका स्ट्राइक हो रहा है वो एज कंपेयर टू इनलेट उसका वॉल्यूम कम होगा, स्लाइटली कम होगा, बिकॉज some amount of volume will fall to the tail race. Okay, so here the ratio of volume of water actually striking the runner to the volume of water which is supplied to the turbine is called as your volumetric efficiency. Okay, here eta v is denoted as the volume of water actually striking the runner divided by volume of water supplied to turbine. I hope you understand this phenomenon. It's very simple. Volumetric efficiency. Now the last efficiency is overall efficiency. Okay, overall efficiency is denoted by, as usual, eta o. O stands for overall. Now here overall efficiency is defined as the ratio of power available at the shaft of turbine to the power supplied by water at the inlet of turbine. Okay, here ratio कौन सा है? Power available at the shaft of turbine to the power supplied by water at the inlet of turbine. Okay, so जो रेशो है वो रेशो हम लोग ने यहाँ पे लिखा हुआ है, that is eta o equals to shaft power divided by water power. Okay, shaft यहाँ पे लिखा है power available at shaft of turbine, so this is denoted by sp, and power supplied by water at inlet of turbine, that will be equal to your water power. Okay, so eta o will be equals to sp divided by wp. Okay, now अगर ये इक्वेशन आप देखें तो इस इक्वेशन पे अगर ये इक्वेशन मैथमेटिकली इक्वेट करें RP को, that means your runner power. So for equilibrium we can multiply this by RP divided by RP. Okay, RP divided by RP. But SP divided by RP and RP divided by WP, these are the two different efficiencies. Okay, so here you can see that SP divided by RP is nothing but your mechanical efficiency. So here I have written as SP divided by RP is eta M. Okay, and here RP divided by WP is your hydraulic efficiency. So here RP divided by WP, I have written it as a eta H. Okay, this step is somehow easy. You have to only multiply the overall efficiency ratio by runner power divided by runner power. Okay, runner power divided by runner power. This is simply a mathematical calculation. You have to equate this only. But you have to multiply this by runner power, and that runner power will divide by that runner power will be comes to the denominator of shaft power, and here the water power will comes to the denominator of runner power. Okay, so equation will become shaft power by runner power into runner power by water power. But shaft power by runner power is your mechanical efficiency, and runner power by water power is your hydraulic efficiency. Okay, so overall efficiency eta O, we can calculate overall efficiency by another way also, by multiplying simply mechanical efficiency and hydraulic efficiency. Okay, there are two ways of calculating overall efficiency. First is shaft power divided by water power, and second is mechanical efficiency into hydraulic efficiency. Okay, this is about the efficiencies of hydraulic turbine. Okay, up to this we have covered hydraulic efficiencies of hydraulic turbine, heads of hydraulic turbine, and the layout of general hydroelectric power plant. Now we'll move further for the classification of hydraulic turbine. Now hydrauलिक turbines जो है वो according to different heads they can be classified in several types. We'll discuss one by one. First is according to the type of energy at inlet. According to the type of energy at inlet. Second type is according to the direction of flow through runner. Third is according to the head at inlet of turbine. And last is according to the specific speed of turbine. Okay, under these four heads there are again subtypes. We'll explain this. Now first type is according to the type of energy at inlet. Under this head there are two types: impulse turbine and reaction turbine. Okay, now what is impulse turbine? if at inlet if at inlet of turbine the energy available is only kinetic energy, then that turbine is called as impulse turbine. ओके, इम्पल्स टर्बाइन क्या है कि जो टर्बाइन का इनलेट है वहां पे जो एनर्जी है, इफ दैट एनर्जी इज ओनली काइनेटिक एनर्जी, देन द टर्बाइन इज कॉल्ड एज योर इम्पल्स टर्बाइन. ओके, एंड what is reaction turbine then? When the water flows over vents, pressure is atmospheric, okay, from inlet to the outlet of turbine. Okay, if if at the inlet of turbine the water possesses kinetic energy as well as pressure energy, then that turbine is called as reaction turbine. Okay, इम्पल्स में ओनली काइनेटिक एनर्जी कंसिस्ट करते हैं, रिएक्शन में काइनेटिक एनर्जी प्लस प्रेशर एनर्जी कंसिडर करते हैं। ओके, मतलब इम्पल्स टर्बाइन इफ एट द इनलेट energy available is only kinetic, then that is impulse turbine. And if at inlet of turbine the water possess kinetic as well as pressure energy, then that turbine is called as reaction turbine. Okay, now uh, second head is according to the direction of flow through runner. According to the direction of flow through runner. Now, under this head, there are again four types. First is tangential flow turbine. Now, tangential flow turbine is if water flows along the tangent of runner. That means if water flow along the tangent of runner, then that is known as tangential flow turbine. Second is radial flow turbine. If water flows in radial direction through runner, if water flows in radial direction through runner, then that turbine is called as radial flow turbine. अगर टेंजेंशियल डायरेक्शन रनर के टेंजेंशियल डायरेक्शन में फ्लो हो रहा है तो टेंजेंशियल फ्लो टरबाइन, रेडियल फ्लो हो रहा है तो रेडियल फ्लो टरबाइन. नाउ एक्सियल फ्लो टरबाइन. Axial flow turbine means if the water flows through runner along the direction parallel to the axis of rotation of runner, then that is called as axial flow turbine. Okay, means जब भी वाटर रनर के एक्सिस को पैरेलल फ्लो करेगा, that is called as axial flow turbine. And mixed flow is if water flows through runner in the radial direction but leaves in direction parallel to the axis of rotation, then that is called as mixed flow. मतलब वाटर एंटर कर रहा है रेडियल डायरेक्शन में एंड लीव कर रहा है एक्सियल डायरेक्शन में, सो दैट इज कॉल्ड एज मिक्स्ड फ्लो टरबाइन. ओके, now according to the head at inlet of turbine. According to the head at inlet of turbine, under this head there are three types: high head turbine, medium head turbine and low head turbine. These are very simple. मतलब जो इनलेट है टरबाइन का, वहां पे जो भी हेड से आपका वाटर स्ट्राइक हो रहा है, अकॉर्डिंग टू दैट हेड दीज आर थ्री टाइप्स. हाई हेड से स्ट्राइक हो रहा है अगर एच हाई है तो दैट इज हाई हेड, मीडियम हेड है तो मीडियम हेड, लो हेड है तो लो हेड टरबाइन. ओके, नाउ द लास्ट टाइप इज according to the specific speed of turbine. Okay, जो टरबाइन की स्पेसिफिक स्पीड है, अकॉर्डिंग टू दैट स्पेसिफिक स्पीड the water the turbine is again divided into three subtypes. That subtypes are low specific speed turbine, high specific speed turbine and medium specific speed turbine. Okay, these are according to the specific speeds of turbine. Now the specific speed phenomenon I'll explain in further videos. Specific speed is nothing but the speed at which turbine runs when it is working under a unit head. Okay, for that you have to understood what is unit head, unit power. So these are the unit quantities. For this, for up to this only you have to remember that according to specific speed also there are three subtypes. Okay, now this is about the classification of turbine. In this classification The radial flow turbine is further inward and outward radial flow turbine. Okay, now I'll explain what is inward radial flow and outward radial flow. रेडियल फ्लो क्या है कि अगर वाटर जो है वो रेडियल डायरेक्शन, रनर के रेडियल डायरेक्शन में स्ट्राइक हो रहा है और फ्लो हो रहा है, तो दैट इज कॉल्ड एज योर रेडियल फ्लो टर्बाइन. ओके, दिस इज आई हैव एक्सप्लेन. बट इफ water flows from outward to inward radially, then that turbine is called as inward flow turbine. Okay, outward to inward flow हो रहा है radially, तो that turbine is called as inward radial flow. And if water flows radially from inward to outward, then that turbine is called as outward radial flow turbine. Okay, जब outward से inward जाएगा तो inward radial flow होगा, and inward से outward जाएगा तो outward radial flow होगा. These are the subtypes of radial flow turbine. You have to study this also. This is about the classification of general turbines. Now we'll move further for specific Pelton wheel turbine or Pelton turbine. Okay, uh, Pelton wheel or Pelton turbine is a tangential flow impulse type of turbine. Okay, that means ये टेंजेंशियल फ्लो टरबाइन भी है एंड इम्पल्स टरबाइन भी है. दैट मीन्स उसके इनलेट पे ओनली काइनेटिक एनर्जी होगी, वाटर possess ओनली काइनेटिक एनर्जी एज दिस इज द इम्पल्स टरबाइन. एंड टेंजेंशियल फ्लो भी है, दैट मीन्स वाटर विल फ्लो इन टेंजेंशियल डायरेक्शन टू द रनर. ओके, नाउ दैट म्हणजे वाटर जो भी स्ट्राइक होगा रनर पे, दैट विल बी अलोंग द tangent of the runner and energy will be only kinetic energy. Now the pressure at inlet and outlet of turbine on Pelton wheel is atmospheric. Okay, thus the turbine is used for high heads. Okay, thus this turbine can be used for high heads. Now Pelton wheel turbine जो है वो this Pelton wheel turbine is named after the L.A. Pelton. This is the American engineer. So Pelton wheel is named after the L.A. Pelton engineer. Okay. Uh, this is the name of a engineer. Now this diagram shows the general layout of Pelton wheel turbine. Before this, I'll explain what are the parts of Pelton turbine. Firstly, in this reserve layout, the I'll show the diagram first. In this layout of hydroelectric power plant, in which turbine is Pelton wheel turbine. Okay, this is the general Pelton wheel turbine which is shown in the layout of hydroelectric power plant. Now the water from reservoir flows through the penstock at outlet of which nozzle is fitted. The nozzle increases kinetic energy. Okay, here this nozzle increases the kinetic energy of water flowing through penstock. At outlet of nozzle, the water comes out in the form of jet and strikes at the vents. Okay, now the main parts of this turbine, Pelton wheel turbine, are nozzle or and flow regulating arrangement, runner and bucket, casing and braking jet. Okay, first is nozzle and flow regulating arrangement. What is nozzle? Nozzle you have already familiar with it. Nozzle is nothing but the uh, end point of your pipe which is having small diameter than pipe. Now here the amount of water striking the buckets or vanes of the runner is controlled by providing a sphere. Okay, here sphere is provided so that we can control the amount of water which is striking on the vanes. Okay, now sphere is the conical needle. Here you can see that this is in the shape of needle, conical needle, at the end point of which wheel is provided. Okay, this is your penstock and this is your nozzle. Okay, now this is your spear which is having a shape of conical needle at the end of which a wheel is provided. Okay, now this wheel can be operated by hand manually or can be operated automatically to adjust the flow of the water through nozzle. Now when the spear is pushed forward into nozzle, then the amount of water striking amount of water striking to the runner will be decreased. Okay, and when this is pulled backward, then what happened, the amount of water which is striking on the runner will be increased. जब भी ये forward push करेंगे तब this area will decrease, so that the amount of water will decrease which is striking the veins. and जब भी ये बैकवर्ड पुल करेंगे तब ये एरिया इंक्रीज हो जाएगा वाटर का, एंड द अमाउंट ऑफ वाटर will also increased. Okay, so we have to remember two things: when we are going to push forward, then amount of water will increase, and when we are going to pull backward, then amount of water will decrease. Amount of water will increase, sorry. Forward amount will decrease, backward amount will increase. Second is runner and bucket. As I have explained, runner is nothing but the conical shape part, circular shape part. This figure shows the runner, circular part. This figure shows runner. It consists of a circular disc on the periphery of which number of buckets are provided. Okay, and these buckets are evenly spaced and fixed. Hmm. These are called as vanes. The shape of bucket is double hemispherical cup or bowls. These are double hemispherical cup shaped or bowl shaped. Okay, now each bucket, each vane is divided into two symmetrical parts. जो दो यहाँ पे ये बकेट शेप का है, एंड ये जो ईच पार्ट है, ये पार्ट ये जो एक बकेट है वो दो पार्ट्स में डिवाइड किया हुआ है. ओके, नाउ जो डिवाइड किया हुआ पार्ट है उसके जो मिडल की रिज लाइन होगी, दैट लाइन इज कॉल्ड अ स्प्लिटर. ओके, दैट मीन्स व्हेन जेट ऑफ वाटर strikes the splitter, that splitter will divide the jet of water in two equal parts. Okay, and at the outer edge, the water will comes out. Okay, and the water will comes out in the angle of 160 degree or 170 degree. That means deflection angle is 160 or 170 degrees. Okay, these buckets or veins are made up of cast iron or cast steel, bronze और stainless steel. Okay, अभी ये जो होगा वो डिपेंड करता है कि आपका हेड कितना है एट इनलेट, तो उसके हिसाब से हम लोग ये कास्ट आयरन, कास्ट स्टील, ब्रॉन्ज और स्टेनलेस स्टील का बना सकते हैं. ठीक है, थर्ड पार्ट इज योर केसिंग. In this diagram again you can see the casing part. This dotted portion is your casing. Okay, casing is nothing but the function of casing is to prevent the splashing of water and to discharge the water at the tail race. Okay, जब भी water strike होगा तब जो भी water बाहर आ रहा है, to prevent that water the casing is provided, and so safely the water will transmit to the tail race. Okay, it also act as a safeguard against the accidents. Hmm. Now it is made up of cast iron or fabricated steel plate. केसिंग जो है वो पेल्टॉन व्हील के वर्किंग में कोई भी परफॉर्मेंस नहीं देता. इट ओनली एक्ट एज अ सेफ गार्ड, ओके, उसका कोई भी हाइड्रोलिक फंक्शन नहीं है। द लास्ट पार्ट इज योर ब्रेकिंग जेट। हम्म अभी जब नोजल जो है वाटर का वो कंप्लीटली क्लोज किया आपने हमने, ठीक है, तब भी क्या होगा कि वेन्स और रनर जो है वो मूव करते रहेगा, सर्कुलर मूव करते रहेगा, क्योंकि उसे काइनेटिक एनर्जी गेन हो गई है, ठीक है, तो वो सर्कुलर करते रहेगा, सर्कुलर फ्लो करते रहेगा। दो योर वाटर इज नॉट स्ट्राइकिंग टू दैट जेट, स्ट्राइकिंग टू दैट वेन्स, अभी उसकी मोशन स्टॉप करने के लिए इन द अपोजिट डायरेक्शन वी हैव टू अप्लाई a jet of water, okay, that jet of water which is applied in opposite direction to stop the motion of runner, that is called as your braking jet, okay, that jet of water is called as braking jet. That nozzle, that uh, part provided is very small, because the function is only to stop that runner only, okay. So up to this we have covered the parts of Pelton wheel turbine now, and working of Pelton wheel turbine. After this we'll move for velocity triangles and the parts points to be remember while calculating the power by Pelton wheel turbine, okay. I hope you understood what is turbine and what are the different parts of turbine, classification of turbine, and efficiencies, and also the heads of turbine. Okay, thank you.